Welcome to Educator.com. In today's lesson, we're going to be discussing solving inequalities. Recall the properties of inequalities, and these are needed to solve inequalities. And the first one is that if A is greater than B, and you add the same number to both sides, this inequality has the same solution set as the original inequality. And you can think of this using numbers to make it clearer. So if I said that 6 is greater than 5, and then I decided to add 2 to both sides, 8 is greater than 7. So this still holds up. So you're allowed to add the same number to both sides of an inequality. And that is true for both greater than and less than. And it's also true for greater than or equal to and less than or equal to. The subtraction property states that if A is greater than B and I subtract the same number from both sides, then the resulting inequality has the same solution set as the original inequality. So the same idea as up here. If I have 6 is greater than 5 and I subtract 3 from both sides, I'm going to end up with 3 is greater than 2. So that still holds up. And that also is valid for less than and for greater than or equal to and less than or equal to. With multiplication properties, if A is greater than B and a positive number, so C is greater than 0, a positive number, the same positive number is multiplied by both sides of the inequality, then the solution set of the resulting inequality is the same as that of the original inequality. So if I have, 3 is greater than 2, and I multiply both sides by 4, I'm going to end up with 12 is greater than 8, which is still valid. Same for less than. A is less than B. You are allowed to multiply both sides of the inequality by the same positive number without changing the solution set. Again, this applies to greater than or equal to and less than or equal to, as well as to strict inequalities. The case is different for negative numbers. If C is less than 0, so if you are multiplying both sides of an inequality by a negative number, you must reverse the inequality sign. If both sides of an inequality are multiplied by the same negative number, the direction of the inequality must be reversed. And if you do that, then the resulting inequality has the same solution set as the original inequality. If you don't reverse them, the solution set will not necessarily be the same. For example, if I have 8 is greater than 4, and I multiply both sides by negative 2, let's say I didn't reverse the sign. Then I'm going to end up with negative 16 is greater than negative 8. And this is clearly not true. So as soon as I multiply by a negative number, this is incorrect. As soon as I multiply by a negative number, I immediately have to reverse the direction of the inequality. And that'll give me negative 16 is less than negative 8, which is valid. And again, the same for greater than or less than or equal to. So multiplying by a positive number, the solution set of the resulting inequality is the same as the original. Multiplying by a negative number, you need to reverse the inequality sign in order for the solution set for this inequality to be the same as for the original. Similar idea with division. If you are dividing both sides of an inequality by a positive number, the resulting inequality has the same solution set as the original. That's only if it's for a positive number. So 15 is greater than 20. If I wanted to divide both sides by 5, I could do that. And I don't need to do anything to the inequality. I just keep it the same. And that's going to give me 3 is greater than. Well, I need to start out with an inequality that is valid. So if 20 is greater than 15, and then I multiply the same, I divide the same number by both sides, So I'm starting out with 20 is greater than 15. 20 divided by 5 is greater than 15 divided by 5, which is going to give me 4 is greater than 3, which is true. Same holds up for less than and greater than or equal to, less than or equal to. Now, if we're dealing with dividing by a negative number, you have to reverse the inequality sign, and then that resulting inequality is the same solution set as the original inequality. So if I have 4 is less than 6, and I divide both sides by -2, I need to immediately reverse this inequality symbol. And then I'm going to get 6 divided by -2, and I end up with -2 is greater than -3, and that is valid. If I hadn't reversed this, I would have got something that is not valid or does not have the same solution set as the original. So you need to be very careful as soon as you multiply or divide by a negative number when you're working with inequalities that you reverse the inequality symbol. There are multiple ways of describing the solution set of an inequality. You can either express it as a graph, a set, or simply as an inequality. For example, if I came up with the solution set x is greater than or equal to 2, I could just leave it as an inequality like that. That's a little less formal. I could describe it as a set using set builder notation. And I would put it as follows. So what this is saying is the set of all x such that x is greater than or equal to 2. So this is set builder notation, and the set of all x such that x is greater than or equal to 2. This is the same, you'll see the same thing sometimes with 2 dots here. This is more common, but you will see this sometimes, and it means the same thing. You can also use a graph on the number line. You can express it as a graph. And remember that if you're saying greater than or equal to, you're including this number 2 in the solution set. So in that case, you would want to use a closed circle and then continue on to the right. Now, let's say I was going to say x is less than 3. In this case, it's a strict inequality, and 3 is not part of the solution set, so I'm going to use an open circle. So you can express an inequality, the solution set, either using set builder notation, using a graph, or less formally, just as a simple inequality. Looking at example 1, we have -3x is less than -27. So I need to solve that. I need to isolate this x, and in order to do that, I'm going to need to divide by -3. But as soon as I start thinking about dividing by a negative number, got to reverse the inequality symbol. So instead of less than, this becomes greater than. So this is going to give me x is greater than 9. I can leave it just as an inequality. I can use set notation to show this. I can also graph it on the number line. Okay, and graphing it on the number line, I'm going to use an open circle since it's a strict inequality and show that x is greater than 9, but that 9 is not part of the solution set. Solve -4x minus 7 is greater than or equal to 9. The first step is to add 7 to both sides to get -4x is greater than or equal to 16. Now, to isolate x, I need to divide both sides by -4, and as soon as I do that, I'm going to change this direction to less than or equal to. 16 divided by -4 is -4. So the solution is x is less than or equal to -4. Using set notation and graphing on the number line, multiple ways. So -1, -2, -3, -4. And this is saying less than or equal to. Therefore, -4 is going to be included in the solution set as indicated by a closed circle. Okay, in example 3, it's a little bit more complicated, but you just handle it using the same principles. When you're dealing with fractions, the best thing to do is to get rid of them first because they're difficult to deal with. So I'm going to multiply both sides of the equation by -9, and since that's a negative number, immediately reverse the inequality symbol so that you don't forget to do that. This is going to be -9 times -2 times 3x minus 6. Move this over a bit. And that is plus -9 times 4x divided by -9. It's greater than -3 times -9. Okay, so -9 times -2 is 18 times 3x minus 6. These negative 9's cancel out, and that's going to give me plus 4x is greater than -3 times -9 is 27. Using the distributive property, I'm going to multiply this out, and 18 times 3x is 54x. 18 times -6 is -108. Plus 4x is greater than 27. Now I need to isolate this x, so first I'm going to combine like terms. I have 54x plus 4x is 58x. Minus 108 is greater than 27. Adding 108 to both sides will give me 58x is greater than 27 plus 108. So it's 58x is greater than 135. So x is greater than 135 divided by 58. So I can leave it like that, or I could use set notation. To graph this, you need to figure out, if you divide 135 divided by 58, it's a little bit larger than 2. It's approximately 2.3. So I could go ahead and graph that out as well. So 2 is here, 2.5 is about there, 2.3 is about right here. Open circle at 2.3, or actually right over here. 1 is here, 2 is here, 2.5 is about here. So 2.3 is going to be right about here. And that is open circle, like that. So 3 ways to express the solution. Okay, in example 4, again, a little bit more complex, and there is a fraction, so we're going to get rid of that first. So start out by multiplying both sides by -7, which tells me that I immediately need to reverse the sign. So -7 times -3 times x minus 4 over -7 plus -7 times 3 times 9 minus 2x. Reverse the inequality symbol. Greater than or equal to -7 times 4 minus x. Okay, this cancels. That gives me -3 times x minus 4. And this is -7 times 3, so that's minus 21 times 9 minus 2x. It's greater than or equal to -7 times 4, that's -28. -7 times -x, that's plus 7x. So now I just need to do some more simplification. -3 times x is -3x. -3 times -4 is plus 12. -21 times 9 is -189. -21 times -2x is plus 42x. And this is -28 plus 7x. Can't really do anything with that. Okay. Now, I'm going to combine like terms. And I do have some like terms. I have a negative 3x and 42x. Combining those, I'm going to get 39x. Negative 189 plus 12 is negative 177. Next step is to isolate the x. So I'm going to add 177 to both sides. That's going to give me 177 minus 28 plus 7x. Subtract 7x from both sides. 39x minus 7x is greater than or equal to 177 minus 28. Combine like terms to get 39x minus 7x is 32x. Is greater than or equal to 149. Now I'm going to divide both sides by 32, and it's a positive number. So it just becomes x is greater than or equal to 149 divided by 32. Using set notation, x is greater than or equal to 149 over 32. You could also graph this. This is approximately equal to 4.7. So 0, 1, 2, 3, 4, and 5. It's going to be a little over halfway between 4 and 5. Close circle and graph it. Okay, so first step was to eliminate the fraction by multiplying both sides of the equation by negative 7 and reversing the inequality symbol. Once that was done, using the distributive property to multiply everything out and get rid of the parentheses, then using the addition and subtraction principles and combining like terms to simplify this equation, this inequality. And the result was x is greater than or equal to 149 over 32. That concludes this lesson on solving inequalities at educator.com. See you again.